Day-5spherical mirrors. The left hand side shows a disc antenna and mirror is concave. Focus of mirror is also there at which the sensor is placed. In the middle figure, doctor is checking the teeth of a patient and cavities can be identified by using concave mirror. In the right hand side, convex mirror is used as a rear view mirror used in two-wheelers, four-wheelers along with driver's side in the vehicle. We can use a spoon also, just like a convex mirror, as a concave mirror. The cavity side of the spoon gives concave mirror and opposite side gives convex mirror. In the left hand bottom side, the spoon is showing a convex mirror, whereas at the last corner the spoon is showing a concave mirror with a bigger size of image. Concave mirror versus convex mirror. Curved mirrors are of two types. One is concave, another is convex. Let us identify. We have seen also in the case of a spoon, when there is a cavity which is reflecting light, then the mirror is concave mirror and opposite to it, convex mirror. A concave mirror is a converging mirror, means collecting amount of light at its focus, or it may be at other point depending upon location of object. We will do it in various ray diagram. Convex mirror is a diverging mirror, that is spreading light after reflection on mirror. Mirror as a part of a sphere. Concave mirror. Here is a hollow sphere and a part of it is cut. When it is painted outside, that is inner side of the hollow sphere is a reflecting surface, then it is a concave mirror. And in case of painting or polishing in the inner side and reflecting surface is outer, then it is a convex mirror. There are various points on the geometry, say point P in both the cases, that is known as pole. Pole is geometric center of a mirror and center of curvature is the point of, that is center of sphere from which the mirror is cut off. The extended line joining pole and center of curvature C is known as principal axis. The distance are measured from pole. Distance of center of curvature from pole is known as radius of curvature. Rules of image formation. Mirror is shown in the first figure and principal axis starting from P and it is passing through F focus and C center of curvature. This extended line is always normal to the mirror surface. Therefore, incident ray makes an angle I, which is equal to angle of reflection R, according to the laws of reflection. In the laws of reflection, angle I is equal to angle R, and incident ray, reflected ray, normal lie on the same plane. In the second diagram, there is a mirror in which the ray of light is coming parallel to the principal axis, and dotted line CM shows here center of curvature line passing and falling on the mirror, that is normal again. Any line passing through center of curvature becomes a normal on the surface of mirror. Just like in the first case, principal axis is a normal passing through center of curvature. Similarly, in another case, second one, principal axis is not there. There is dotted line, and that is passing through center of curvature is normal again. The incident ray makes an angle I with normal CM in the figure 2. Therefore, according to laws of reflection, I is equal to R. The reflected ray reflected at the point M on the mirror makes angle R and passes through a point on principal axis that is known as focus F. In the figure 3rd at bottom, ray of light incident at pole P, angle of incidence is equal to angle of reflection in case of convex mirror, that is laws of reflection follows on reflecting surface, either it is convex, concave or plane mirror. In the figure 4, object is placed at infinity. Rays of light coming from infinity are always parallel to principal axis. They fall on convex mirror, and first the normal dotted line coming from C to M gives here direction of normal. Then angle of incidence I is equal to angle of incidence reflection R. I is equal to R, both becomes equal, and the incident ray reflects from convex mirror on its reflecting surface MN. Rules of image formation. Number 1. Any ray coming parallel to principal axis after reflection from a mirror passes through focus, that is a point on principal axis as shown in the figure. AB incident ray of light after reflection passes through F, and that is BD, reflected ray. Similarly, in the other figure, convex mirror, incident ray falls on mirror, and then normal is drawn from center of curvature, that is CO, shown in figure. Angle of incidence I is equal to angle of reflection R according to laws of reflection. In the first figure, a ray of light, blue color ray is shown in the figure, coming from center of curvature. Then any line, either it is principal axis or any ray of light coming from center of curvature falls normally, that is makes angle 90 degree with the surface of mirror. Therefore, it is reflected back on the same path, that is, there is a single line shown in the figure, incident ray, reflected ray, both trace the same path. In the second figure, there is a convex mirror. Incident ray of light AD falls on mirror MN in the direction of normal, that is passes through center of curvature and reflected back due to I is equal to 0 and R is equal to 0. In case of normal incidence, angle of incidence I is equal to 0 and angle of reflection R is equal to 0. In the first figure, ray of light coming parallel passes through focus on concave mirror. Similarly, on convex mirror, this ray of light reflects on the reflecting surface and appears to come from focus. In the third figure, there is a concave mirror. This is just example of a headlight of car or bus or two-wheeler, we can say also, in which bulb is placed at focus and rays of light falls on a concave mirror. Then they become parallel after reflection on concave mirror. In the last diagram, rays of light coming parallel to the principal axis makes angle I with normal center of passing through center of curvature. Then I is equal to R and it is behaving like a diverging mirror. Now the rear view mirror is used at the side of a driver in two-wheeler and four-wheeler to observe large area behind the two-wheeler or four-wheeler. That is, a small area can be used to observe object behind the vehicle. And the ray diagram also shows here ray of light is coming from field of view in both sides, upper side and bottom side. Then it makes angle I, angle of incidence, with normal passing through center of curvature, that is a dotted line. I is equal to R, angle of incidence becomes equal to angle of reflection according to laws of reflection, and this ray of light arrives in driver's eye sitting in the vehicle. Therefore, this driver can observe the back area, that is very large in comparison to the size of mirror, and in the figure it is shown as field of view.